Hello there, welcome to the video lectures of engineering mechanics. In this problem, we are going to be see the concept of the moment. Already we have learned what is the moment. So we learned the moment is equal to the force into perpendicular distance. So in this case, the product of the force as well as the perpendicular distance. So in the given problem, most of the time in the given problems, we need to find out the magnitude of the force, right? At the same time, some of the geometrical properties also we need to be calculated. There we can see the force, the parameter is required. At the same time, the perpendicular distance also we need to measure. So then from this problem we are going to be seeing. So here a uniform wheel of 600 mm diameter, right? A wheel has given that consists of 600 mm diameter weighing 5 kilonewtons. The rest against a rigid rectangular block of 150 mm height. So here is the height of the block is going to be 150 mm. As shown, find the least pull through the center of the wheel required just to turn the wheel over the corner A of the block. There we can see we are applying the force P, and where that least, that is the minimum amount of the force we are applying, so that it will try to turn on the block A. Also find the reaction of the block. So from this one I am going to be take the given data. What is available? The diameter of the wheel is available 600 mm, right? At the same time, that's going to be weight of the wheel is going to be around the 5 kilonewtons he has provided. At the same time, there is a rigid block height he has given, that h is going to be the 150 mm, right? And they are going to be rested on the horizontal plane, and there is a rigid block is going to be a corner to that wheel. So, and just to turn. So he has given the word is that just to turn. So this is going to be helpful in your the next level of the problem solving. The wheel over the corner A. So then find also the reaction force. That means we need to be find out the force P as well as the reaction force RA we need to be calculate. So that means the reaction is going to be over here. So now with this data, I am going to be try to draw the free body diagram. The free body diagram will helpful to you to analyze the forces what are going to be acting on that member. At the same time, it is going to be helpful to apply the equations of equilibrium, and then we are going to be solving this problem. So now we are trying to draw the free body diagram for the wheel. So I am going to be magnifying the wheel so that we can give the dimensions very easily. So this is going to be your center of the wheel. At the same time, it is going to be rested on the horizontal plane. When I am going to be removing the horizontal plane, so then what happened? The ball we have to show with the reaction forces. While you are drawing the free body diagram, the first we need to remove all the supports, just like walls or other body or the hinges or supports, whatever it may be, that's we need to remove it. And we need to show with the reaction force. But in this case, they had given one. The clue is that just to turn, right? Just to turn means it's leaving the contact with the horizontal plane, and it is going to be trying to mount at the point A. So in this case, what I am going to be, the self weight is going to be acting always in the downward direction. That is the W I have taken, right? At the same time, the force P is going to be acting towards this side. That is going to be already mentioned. And can you see there is a contact is going to be existed between the wheel as well as the block. So that block height also he has given. This is going to be your point A. So in this case, when I am going to be removing this block, that I want to show with the reaction force. So the reaction force I am going to be taking in this direction. So can you see this is going to be your reaction force is going to be RA I am going to be considering, right? And it is going to be making with an angle with the vertical or maybe to the horizontal. That's we need to be calculated. Can you see the height of this one from the supporter, that means from the horizontal plane to from here is going to be 150 mm height is going to be there. So now by using this one, as we know, the moment is going to be force into perpendicular distance we need to be calculated. Now where we need to take the perpendicular, that means the moments. If I am going to be taking the moments at C, so then what is the problem here? This means all the forces are passing to this one. So the magnitude of the force is available, but the perpendicular to the point to the line of action is going to be 0. So then at the point C is going to be not possible. So if I am going to be taking at A, so then what happened? The P force I don't know and RA force I don't know. It means that I am going to be making intentionally one of that force is going to be 0, so that I can calculate by using the equation, and then I can calculate that part. So now what I am going to do, I need to be find out, I know the forces. What are the forces? RA, W and the P. The three forces are going to be available to you. That means not in terms of the numerically, but somehow that is characteristically that is available. But now I need to be find out the perpendicular distance, right? The perpendicular distance I need to find out. That means if I am going to be taking the moments at A is equal to 0. So now whatever the forces we are going to be taking, that line of action to the point of observation perpendicular distance we need to be measured. Now we can see I am going to be taking the point A over here. So then what is the distance? I am going to be draw a perpendicular line. Can you see? So this is going to be the perpendicularity we are going to be say. As we know that the height from this point to this point is going to be the 150. Right, from this point to this point is the 150, because the diameter of the wheel is going to be 600. The point it is going to be the suppose BC height is going to be the 300. That is going to be your radius is equal to 300 mm. On that basis we are getting BC is equal to be 300. When the height of the block is going to be 150, then this point I am going to be say the D, suppose. So the DC distance is going to be also we are getting 150 mm. And what is the AC? The AC is going to be representing the radius of your wheel. So that is going to be 300 we are going to be getting. So now we need to be find out the inclination certain part. So what is the AD distance? We need to be find out the perpendicular distance. That is, this is going to be your line of action and this is going to be your point of observation, that I want this distance. So by seeing this one, it is reflecting the Pythagoras theorem. So then what I am going to be getting here, that's going to be AD square is equal to, so that's going to be AC square minus DC square I am going to be taking. If I am going to be taking the square towards this side, that's going to be the square root. So that is equal to 300 square minus 150 square, that's going to be all to the. So now what is the after the simplification, what is the value of AD I am going to be getting? So AD is equal to, can you tell me what is the value of AD here? So as for my knowledge point of view, after the simplification of this equation, I got around 259.8, that is nearly 260 mm. So and the distance here is going to be 260 mm we are going to be getting. So once if I am going to be calculated here, the perpendicular distance of this one AD is equal to 260 for this one. At the same time, there is another force is going to be existed, that's going to be the force P. So this force P, what is the perpendicular distance? Because it is there existed some inclination. So then what I am going to do, I am going to be draw a line which is going to be making perpendicular to the. Can you see this line? I am going to be representing the perpendicularity, and can you see here I am going to be taking the perpendicularity. Can you see? So then we know that this is going to be the 300 mm distance is available, right? And we don't know what is this is the point C and this is going to be the E. We don't know the distance between point C as well as the E and A to E. So what I am going to do, by using this 300 mm, I am going to be trying to solve this problem. If I am going to be considering, this is going to be your inclination. So can you see, I am going to be draw the diagram of your ACE, that is going to be the triangle. So can you see here, that point I am going to be taking, this is your point A. And can you see here, A to E is going to be existed in this perpendicularity. At the same time, E to C, this is going to be the point, and this is going to be joining. Can you see, the diagonal of the AC is going to be representing the 300, and this point is going to be representing the alpha. So by using this one, I need to be calculate the different inclinations over here. So after drawing this AEC diagram, I want to find out the perpendicular distance. Can you see, AC is going to be inclined and AE is going to be suppose if I am going to be taking the line of action, this is going to be the perpendicular distance, right, to the point of observation. So then what I am going to do, I need to find out the AE, that is your perpendicular distance. Suppose for this one, I am going to be taking here, this is going to be AEC, that suppose this is going to be the 90 degrees. At the same time, at the point C over here, it is making an angle of alpha. So I am going to be taking here is going to be sine alpha is equal to, what is the sine alpha? That is going to be your opposite side is AE divided by hypotenuse here is going to be the AC. So from this one, AE is equal to AC, we know that is going to be 300, and this is going to be your sine alpha. Can you see here the perpendicular distance to the point A to the line of action of the force I have taken in terms of 300, that is the radius of your wheel, and the sine alpha. So now I am going to be taking the moments at A so that I can calculate the P value. Once if the P value is calculated, then I can calculate the RA also. So now I am taking the moments at A equal to 0. So can you see what are the forces we have? That is going to be the applied force as well as the self weight of the system. If I am going to be taking at the moments A, because RA is passing to the same point and the perpendicular distance is going to be 0, that's already we discussed. Now I am going to be taking the sign conventions. What is the sign conventions here? When the object is going to be moving towards this side, this is the clockwise direction and this is the anti-clockwise direction. I am going to be considering anti-clockwise direction is going to be the negative and the clockwise direction is going to be the positive. So as for your convenience. So now what I am going to do, I am going to be taking here. So this is going to be the negative and this is the positive. So the self weight is going to be trying to move in the clockwise direction. That's going to be W into A, D is the distance, minus this is the load P is going to be acting. So that is going to be perpendicular distance is going to be your AE, that is equal to 0. The summation of all the moments about a point is equal to 0. Now I want to calculate the force P. So then the P is equal to WAD divided by AE I am going to be taking. The division of your geometrical properties. As we know, AD is equal to 260 mm, AE is equal to 300 sine alpha. So I am going to be substituting, what is the W? That's going to be 5 kilonewtons. I am going to be taking the 5 as it is. And AD is equal to 260 divided by, that's going to be 300 sine alpha. If I am going to be simplifying this equation, I am going to be getting some numerical divided by sine alpha. This sine alpha is going to be deciding whether it is going to be a maximum value or the least value we are going to be take it. Yes, after the simplification, I got around 4.33 sine alpha. So can you see when the P is equal to 4.33 by sine alpha, in this case alpha is going to be the unknown terminology. So then what I am going to do, I want to find out the least value of the force so that the wheel is going to be trying to climb over the point A. So I am going to be substituting here. So here the P is equal to 4.33 sine alpha I have taken. In this case what I am going to, I need to find out the least value, the least force, so that alpha is equal to 0. If I am going to be substituting, then the P is equal to 0 I am going to be getting. Right? If I am going to be substituting alpha is equal to 90 degrees, so that your sine alpha is equal to 1. So alpha is the 90 degrees, so that we will get the 1. So then the P is equal to 4.33 kilonewtons I am getting. This is the least amount of the force that we are applying at the center of the wheel, so that it is going to be climbing on the point A. So after the calculation of your force P, this is the least force is the minimum force, and then we need to find out the RA. So that RA is equal to how much? As we know that by seeing this one, we are going to be trying to resolve the forces into the two components. One is going to be your vertical components and another one is going to be your horizontal component. So once you resolve the horizontal as well as the vertical, we are going to be taking the two types of the forces. One is going to be the reaction force, and second one is going to be the weight, self weight of the member. In this case, we are not going to be using how much amount of the force we are applying on the body to trying to rotate about the point A. right? And these are all going to be the standard forces are coming, because the applied force we have to show. That means already we have calculated that, but the same thing we are not going to be using in our equations. So in this case, sigma f of x is equal to 0 or sigma f of y is equal to 0. That means the summation of the forces in x direction is equal to 0, the summation of the forces in the vertical direction is equal to 0. So then I am going to be resolving this force. One is going to be the vertical, another is going to be the horizontal. It means this is going to be your RA. If I am going to be taking cos 30 degrees, I can take it. And this is going to be your RA sin 30 degrees, you will get it, right? And this component I have the same resultant, I have resolved into the two components. Now what I am going to do, I am using this the vertical forces. So that is equal to, so upward direction is going to be the positive and downward direction is the negative. The sign conventions already we are mentioning. So then what I am going to be getting, this is going to be RA sin 30 degrees is equal to the W. As we know, W is equal to the 5 kilonewtons load. Then RA is equal to the 5 divided by sin 30 degrees. So from this one, we are going to be calculating your RA value. So if I am going to be simplifying, sin 30 is equal to 1 by 2. So that's going to be 5 into 2 I am going to be getting. Then RA, that is the reaction force at the point A, that is going to be 10 kilonewtons. It is going to be developing. As we know that the weight of the ball is only the 5 kilonewtons, but the reaction force developed at the block is going to be 10 kilonewtons. It means that the double amount it has generated, right? Because that load is going to be concentrating only at this point, right? Before there is going to be a contact over here. So the reaction force is going to be coming from the ground. At the same time, while it is moving time, the total load is going to be concentrated and the reaction force is going to be generating this way. This way we are going to be trying to solve the problem. So that means here the moments is equal to force into the perpendicular distance. In this case, most of the time our total time is going to be concentrating to find out the geometrical properties. The geometrical properties is nothing but the length or maybe the arc length or the radius, and we need to calculate it, and the force magnitude we are going to be getting from the given figure in terms of your reaction forces or applied forces. This way we are trying to solve it. I hope you people are able to understand how to calculate, how to determine the perpendicular distance from the point of observation to the line of action of the forces. Once if you are able to habitual, this is going to be very easy to you. I hope you are able to understand. For better understanding, you have to see the continuous video lectures, so that it is going to be, the connectivity will going to be developed in your mind, so that the problem solving are going to be easy. Thank you.